Hey, welcome back to Electrically Constructed. I'm Seth Eckel, Master Electrician, and this is video number 2 of our box fill calculation series. In our last video, we covered table 314.16a. In this video, we're going to cover table 314.16b4. This is the volume allowance required per conductor. Okay, we're also going to go over 300.16, length of conductors. Let's get our code books out and get going. Alright, before we get started, I want to cover one quick code rule. And it's going to be 314.16a. It's not the table, it's the code rule. So why don't you get your code books open, and I'm going to go ahead and highlight this real quick. I'm going to highlight 314.16. Highlight A, box volume calculations, and I'm just going to read it real quick. The volume of a wire enclosure shall be the total volume of the assembly sections and where used. The space provided by a plaster ring, dome covers, extension rings, and so forth that are marked with their volume or are made from boxes, the dimensions of which are listed in table 314.16a. Alright, so let's go ahead, let's highlight space provided, plaster rings, dome covers, extension rings, and so forth, marked with the volume. And let's keep going, let's go all the way down to table 314.16a. So basically what this is telling us is that we need the full assembly of the box. If we're building a box and it has a plaster ring, if it has a dome cover, or it has extension ring, and it's marked with volume, we can use that as part of our total volume for that box assembly. So I have a mud ring right here, and this mud ring has 5.5 cubic inches written on it, so I could use this. If it doesn't have it stamped on it, we can't use it. If I were to use extension ring and it doesn't have it stamped on it, I can still use it because it is part of the table. So if we go to the table and we look, this is extension ring. It's a 4 square. It is 1.5 inches deep. So I can use the volume for a 4 square 1.5 inches deep right here. 4 square 1.5 inches, 21 cubic inches. So if I were to build a box with using this, I got a 4 square deep right here. I just add it all up together. So 4 square by 2 1/8 is 30.3 cubic inches. This is 21 cubic inches. So if I pull out my calculator, let's take a look. 30.3 plus 21 equals 51.3 cubic inches. So I put these two together. I got 51.3 cubic inches. Now if I add my mud ring to it, I can add the 5.5 cubic inches, so let's add that on. That equals 56.8 cubic inches. Alright, so you don't have to just use the box alone. Once you start putting your assemblies together, you got a lot more volume to add into your box build. But if you don't have a stamp on it, if it doesn't tell you and you have a mud ring, and your mud ring is not going to be on this table, then you can't add volume to it. So something to think about when you are buying parts and pieces. If it doesn't have a volume, and you are short 2 cubic inches of being legally able to put that last wire in your box, you might want to look for a mud ring that has it stamped on there. Alright, yeah, I just want to cover that real quick before we move on. That works for all the boxes. It's the full assembly that you're adding up. Alright, let's go to table 314.16b4, volume allowance required per conductor. Let's grab our highlighter, let's highlight that. So let's go ahead and highlight size of conductor, AWG. Let's highlight inches cubed. Okay, so what this table here is telling us is if we have a mixture of wires in our boxes, we're not going to use this table up here, because this is telling us if you only have this wire, how much can go in that box. But when we have, like, say we have 14 gauge and 12 gauge in the same box, we got to start using these inches cubed allowances right here. So if I had 14 gauge, it'd be one 14 gauge wire is worth 2 cubic inches. One 12 gauge wire is worth 2.25 cubic inches. Let's go ahead and start highlighting this so that it sticks out to us when we're trying to find stuff later on. All right, let's do every other one we've been doing, and I'm skipping the cubic centimeter column because I don't need that. All right, and quickly I'm just gonna show you difference in sizes. So if we start with the 18 gauge, we got 18 gauge wire right here, just some doorbell wire, pretty thin, flimsy stuff. Then we got an example of some 16 gauge wire here, still pretty thin stuff. The jacket on it is thicker because it is some underground cable, but it doesn't matter how thick the jacket is when it comes to box fill. All right, so I got 14 gauge wire. All right, some more common stuff that we're using in our field. Now I got 12 gauge wire. Again, a little bit more common for us to be using as electricians. And I also have some 12 gauge wire with a different jacket on it. Just wanted to show the comparison. So this jacket's obviously a little bit thicker than this jacket, but again, the type of cover on the wire does not matter when it comes to box fill calculations. Got some 10 gauge wire here. Again, a little bit more rigid, a little bit harder to play with when you're inside that box. And then I got some 6 gauge wire and some 8 gauge wire. So here's the 8 gauge wire, here's your 6 gauge wire. Now you're going with some stranded stuff here, so still pretty hard to work with. Trying to bend these in some little device boxes, pretty difficult. All right, now that we understand how much cubic inches each conductor takes up, and we know how to add that up to get our volume, let's go to 300.16. This rule is going to tell us how long a wire has to be inside of a box. So let's go ahead and highlight 300.16, length of free conductor at outlets, junction boxes, and switch points. And let's highlight A, general. All right, and A tells us at least 6 inches of free conductor measured from the point in the box where it emerges from its raceway or cable sheath shall be left at each outlet, junction, and switch point for splices or the connection of luminary or devices. The 6 inches free conductor shall be permitted to be spliced or unspliced. Let's go ahead and highlight at least 6 inches of free conductor measured from the point it comes out into the box from a raceway or a sheath. So that matters. Okay, and then if we keep reading, this is a big one. Let's highlight that. If the opening to an outlet, junction, or switch point is less than 8 inches in any dimension, each conductor shall comply with all of the following. So 1 tells us each conductor shall have free conductor in accordance with 300.16a, which is what we just read. And 2 tells us each conductor shall be long enough to extend at least 3 inches outside the opening. So that's an important one right there. Let's highlight that. So what this rule is telling us is that we have to have at least 6 inches of free conductor measured from the point at which it enters the box, either through the sheath of the cable or through the raceway. So what that means is, as it comes out the sheath, you need to have at least 6 inches of free conductor coming out. Then this rule down here, B2, It's telling us if the box is 8 inches or smaller in any direction. So typical like four square box obviously is 4 inches. In any direction, it's less than 8 inches, you have to have at least 3 inches of free conductor passing the exit of the box. All right, guys, I'm going to give you a quick code question before we finish up here. All right, if I have a box like this and I have a 14.3 running into it and I got a 12.2 running into it, how much volume will these wires add to the box? We haven't gone over yet, but I'm going to let you know right now. On the 14.3, the equipment grounding conductor does not count towards the volume of this box. All right, that's the only clue I'm going to give you right now. I'm going to give you a minute to go over, try to add this up, get your answer, and then we'll go through it. All right, we're back. Okay, so let's go through it. We got 14.3. We're going to count that up first. 14 gauge wire equals 2 cubic inches per wire. So we got the white, we got the red, we got the black. That's going to be 6 cubic inches right there. And then we got our 12.2. 12 gauge wire equals 2.25 cubic inches per wire. So we got our white, we got our black, and we got our grounding conductor. So that's going to equal 6.75. Then we got 6.75 plus 6. It's going to give us 12.75 cubic inches of volume in this box here. All right, one more question for you before we go. What is the smallest 4-inch device box we can use for this volume of fill? I'll give you a second to go over that. All right, and the answer, it is 4 inches by 2 1/8 by 1 7/8 with 13 cubic inches of volume allowed in that box. Okay, guys, that's it. Hopefully you got that question right. If you want more code questions, follow me on Instagram and TikTok. I put out a lot of code questions on those platforms. Other than that, never stop learning. God bless, and I'll see you in the next video.